So here are 4 costly trends that are happening in the industry right now that are driving the need for improved venting in molds. The first trend is that we see increase in material costs that are rising. So plastics over the last 18 months continue to rise exponentially. We don't see that changing, so this is a trend that is going to continue to rise and needs better venting, reduced scrap throughout the whole process and injection molding cycle. The second reason for the need for improved venting is to be able to run recycled resins. So as materials rise and costs rise, we see the introduction 60% rise in recycled content over the next 5 years. So being able to process materials that are recycled with additional heat history to it that tends to be more gassy than virgin resin will require more venting than running 100% pure resin. The third trend that we see in tooling is that molds are becoming more and more complex. So the more complex the mold is, the more opportunities for gas traps, the more opportunities for defects. So properly venting the molds in all those areas will enable perfect parts every time. This reduces scrap, this reduces the defect rate, and produces better uptime and better profitability for molders. The fourth trend that we see that's driving the need for additional venting in molds is that scrap in production is often underestimated. So a lot of times a tooling engineer is required to maintain the mold in the proper condition. However, they're not responsible for the scrap number. That falls into operations side or perhaps downtime. So where a person is not responsible for that level of scrap, those buckets can happen in different areas of the company but not be accounted for aggregately. This is a hidden cost that really drives the problem. So maybe a very simple fix to a mold for a venting issue could drive into the hundreds of thousands of dollars based on rework, the labor to do the rework, the sorting, the extra QA labor, scrap, and additional downtime. So this is an area that we see the need for improved venting to alleviate this issue once and for all. Additive venting works by using the ability to 3D print in different forms the density of the steel. So commonly in injection molding, it's the higher the density of steel. Again, pure density is what we're achieving. However, when we want to vent the mold out, we want to have microscopic pores that are going to allow the gas to escape, but yet dense enough for the plastic not to escape out of the mold. So in additive manufacturing, through the DMLS process, we're able to change the density of a steel in a precision fashion, yet keep full dense steel where it's needed in areas like shutoff, land areas like for ejector pins or other critical areas that venting is not needed in, but just put the venting in an area where it's absolutely required. So the key benefits of using additive venting over conventional means of venting is you're going to get an abundance of venting over compared to conventional venting methods. What this is going to do is it's going to get you to your next PM. It's going to allow you to not have to pull the mold frequently or in an emergency situation or adopt extra cleaning or extra mold maintenance that is an emergency situation and move you more into a preventative maintenance. We often recommend to ultrasonically clean these vents at your PM. This will clean out any of the residue and the buildup and enable the mold to run until the next PM. So this saves you time, it saves you money, and it reduces your defects, which adds to your bottom line.